Next we are moving to the lecture number 2 from energy sources, different type of dry cells. So here, we will consider the following primary and secondary cells. So already in the first part of the video, I explained we have two types of cell, primary cell and secondary cell. Primary cell is not a rechargeable cell. So the chemical reaction is not reversible. In case of secondary cell is a chargeable cell, rechargeable cell. So chemical reaction is reversible, is possible. Okay, right. So in this particular case, we have two types of cell, carbon zinc cell as well as, so here different type of carbon cell, alkaline cell. We have four types, manganese alkane cell and nickel cadmium cell, mercury cell and a silicon oxide cell. After that it is a wet cell, lead acid cell. So these are the dry cells and the only lead acid cell is a wet cell. Wet cell. Okay. Now we are moving to the carbon zinc cell. Okay. So here carbon zinc cell is the oldest and most widely used cell. So in the examination, in the previous year, one of the question, what is the most and oldest carbon cell is a carbon zinc cell. Dry cell is a carbon zinc cell. Okay. Next, the construction. Every battery have two terminals, positive as well as negative. Right, here also zinc can be functions here zinc can be functions of both container to hold the electrolyte and as a negative electrode. In case of carbon, while you are preparing these particular cells, you need to remember two things. What is the electrolyte solution? What about the anode material you are using? What about the cathode material you are using? How much voltage it will be? It is a primary cell or secondary cell? These things are important. Okay, so in this case, positive terminal, negative terminal is a negative electrode. Which is a negative electrode? Zinc can be used as a negative electrode here. Okay, this negative terminal is a zinc. Coming to the positive electrode is a carbon rod. What is a positive electrode? Carbon rod. Down the center but not lower enough. That means this carbon rod is a center. It is not touched with the negative terminal. Okay. It is about the construction. Coming to the electrolyte. What is about electrolyte? The electrolyte is a paste of aluminum chloride and manganese dioxide. What is the electrolyte of carbon zinc cell is a ammonium chloride and manganese dioxide. Okay. All of you clear about the construction? Next we are moving to the size and voltages. It is also important in the cells. So the size and voltage. Such cells are available in several sizes. And open circuit voltage 1.4 to 1.6 volt. Very important. They are asking about the voltages. What is the voltages? Open circuit voltages of zinc carbon zinc cell is a 1.4 to 1.6 volt regardless of size. Larger size have a more zinc electrolyte and depolarize have a higher current rating up to 0.25 amperes to 250 or 250 milliamperes. This is the current rating. The flashlight cell has a current rating of 50 milliamperes for nearly 60 hours of service. That means how much long it is used. In case of 50 milliamperes in flashlight, we can use 60 hours. That is a discharging period. The cells have a highest about 50 mm negative terminal and a diameter of 32 mm. Okay, 52 mm. Here there is no terminal. Clear. Okay. Next we are moving to the carbon zinc batteries are made in many types having a voltages of 3, 4, 6, 9, 13.5, 22.5 and 45 volt. All are multiple 1.5. In some battery cells are cylindrical shape and others they are flat. Okay, this is about the size and shape. So operating efficiency. Carbon zinc cell and batteries are redundant efficiency service provided. They are using intermediary. That means short period at the time of relatively low currents. So where is the application here? Short period and relatively low currents. This type of cells are used. Such operation kept much efficient depolarized. Okay, in case of this particular cells are using in the intermediate load, that means short period as well as low current, we are using this particular cells. Recharging. So dry cells can be recharged if certain precautions are taken. While you are recharging this particular battery, we have to take these particular precautions. What are the precautions here? The precautions are voltage should be 1 volt when removed the service. That means while you are using the, for example, 2 volts battery, while you are using, while you are recharging, whenever it is reached to the 1 volt, we are disconnected from the supply and recharge. There should be one precaution. That means minimum voltage required to recharge again 1 volt. Charging rate should be kept low and spread over 10 to 15 hours. Okay. Recharged cells should be kept used one view, further limited shell life. So this is a shell life is a limited also. So this is about the carbon zinc cell. Okay. Coming to the next cell is a alkaline cell. So here alkaline cell have a different types. We will see one by one. Manganese alkane cell. The first one is a manganese alkane cell. First we can remember this is a primary and secondary cell. So you need to identify. So here it is a primary cell. Manganese alkaline cell is a which cell? Primary cell. So zinc as a anode. We have a two terminals, right? Zinc as a anode and manganese dioxide as a cathode. So you know, zinc as an anode, manganese dioxide as a cathode. Leak-proof steel. That means this is the outer side. We have a steel. It is there. The electrolyte is a potassium dioxide. Already mentioned potassium dioxide or sodium cell. Sometimes sodium cell. Higher current rating than carbon zinc cell. It is a higher current rating somewhat compared to carbon zinc cell. It provides the output voltage. What is the output voltage of manganese cell? They will ask you. What is the output voltage? 1.5 volt. Some alkaline batteries can be recharged as a few times. That means it is not rechargeable generally, but few times it is rechargeable. After that, you can use and throw, like it is a primary cell, right? So sometimes it is rechargeable. Those voltages are 4.5, 7.5, 13.5 and 15 volt. Those are rechargeable batteries. Sometimes you can recharge and then we can't use further. Only few times only rechargeable is possible. Next, nickel cadmium cell. So in the nickel cadmium cell is a dry cell. You know what we discussed, these four cells are dry cells. Okay. So nickel cadmium cell. So here nickel cadmium cell is a dry cell. Okay, it is a rechargeable. It is present days in electronics, you know, nickel iron and lead acid cell compared to nickel cadmium cell is preferred. In the construction point of view, see here. So electrolyte, first of all see the electrolyte, which electrolyte you are using, as well as the anode and positive cathode as well as anode and container. We will see one by one. The action of material cadmium, metal like zinc or alkane, is a power form. It is a pressed perform steel plates which then form negative electrode of the cell. So what is the negative electrode of cell? Steel. It is a pressed and strained into the preferred steel plates. Okay. The positive anode is a steel mesh coated with solid nickel hydroxide. The electrode is a potassium hydroxide. The electrolyte is a potassium hydroxide, usually jelly form. The container is a steel. What is the steel is there? Steel can be sealed after cell is placed. Sealed after cell is placed. These cells are also available in the flat bottom surface. This flat bottom. Okay. This is about the construction. Next, coming to the voltage rating. So here nickel cadmium cells voltage rating of 1.25 volt to 1.5 volt in general. They have a much longer life when compared to rapidly discharges intervals. In fact, long period inactivity can cause the cell fail. So such cells are need to charge at a constant rate, can be recharged up to 1000 times or more. Okay. So these cells have a very low internal resistance. You know, the internal resistance of the particular battery is very low. low internal resistance can be deliver high current rating without losses of terminal voltage. That means I will discuss here. In case of you are connected this battery to the load, this battery voltage is 5, the terminal voltage is also near to equal to 4.5 volt, 4.9 volt, it is okay, good, 0.51 volt only drop. But is 4 volt is present, that cell is a very bad because more internal resistance. But in case of this, in the case of this particular nickel cadmium cell is a very low internal resistance. That means how much of source 5 volt or 10 volt you are giving, or 1.2 volt or 1.5 volt is giving, the same voltage nearly applied across the load. Okay, that is a good point here. The most common nickel cadmium batteries have usually 6 volt, 9.6 volt, 12 volts. Okay, this is a chemical reaction equation. So CD2NiOH plus 2KOH belongs to cadmium oxide CdOH plus 2Ni 2KOH. This type of chemical equations also maybe they will ask. Just remember this chemical equation. Okay, these nickel cadmium cells have a normal load voltage of 1.2, just I know mention, are capable to high current load, 100 cycles of discharge, and in general like abuse short circuited. That means these particular cells also abuse as a short circuited. Somewhat short circuit occur in your circuit, it can be protected. That means not protected, it can be safely, there is no much damage. So this type of cell is one of the advantage here. Uses, coming to the uses, such cells can be easily supply high currents, right? Just now I mentioned, widely used as a source of energy in radios, TV sets, tape recorders, cameras, cordless tape type home appliances, electronic toothbrush, or electric carving knife. They give a good service under extreme conditions of shock vibrations and temperatures. Okay, this type of cells are used. Nickel and cadmium cell. What I points, every point is important. This chapter is a very small chapter. We can expect one question from this particular chapter. I make the one video on previous year questions. Only 4 years 4 questions are there. So this is one of the smallest chapter. We can get one question from there. Okay, mercury cell. So coming to the mercury cell, it is a primary cell. Okay, it is widely used in electronic gadgets. So coming to the construction, you know, this cathode is made up of mercuric oxide and graphite, whereas the anode is highly purified zinc powder. Okay, this highly purified zinc powder is an anode and mercuric oxide is a cathode. So coming to the electrolyte, there are two are separated by the phosphorus material. Electrolyte is a potassium mixture, potassium hydroxide or zinc powder. Okay, coming to the sizes. Such cells are available in wide ranges of shapes and size. The smallest being 3 mm thick and 12.5 mm diameter. This type. Open circuit voltage at room temperature is 1.35 to 1.4 volt. Very very important. Okay, depending upon the electrolyte mixture. With pure mercuric oxide cathode and output voltage extremely 1.3 volt. Mercury battery available in a variety of voltage ratings. Coming to the uses. Mercury cells are enjoying the long life cell without deterioration and are extremely rugged. Yes, since they can provide most constant voltage under varying load conditions. For example, you are providing the voltage of you want voltage of 1.35 volt, constant you want voltage, not variation is not done. That particular case, this type of cells are used. Mercury batteries are widely used in electronic watches, hearing aids and test instruments, etc. Okay, this is about the mercury cell. Coming to the silver oxide cell. Okay, it is a primary cell. Yes, it is a primary cell with open circuit voltage under 1.5 volt. Very very important. You know, in your watches you can see this type of small steel type of battery. This is it is a cathode silver oxide and anode. Okay, very very important. Cathode is a silver, anode of a zinc alkane electrolyte, generally made in bottom size for use in cameras, hearing aids and electronic watches. Okay, these are the silver oxide cells. Okay, just look at here. This particular cell, silver oxide cathode, as well as powder zinc anode, as well as anode cap. This one is a gasket. Okay, this is the structure of silver oxide cell. At the last, lead acid cell, very important. It is a wet secondary cell, very important. Lead acid cell is a wet secondary cell, and mostly making automobile batteries. In the automobiles it is used mainly. Okay, so here the coming to the construction. So here in anode plate, brown colored grid made up of lead antimony alloy, okay, into which pressed the active material, lead peroxide PbO2. The cathode is similar plate having a pure phosphorus sponge like lead as an active material. Two plates are immersed in solution dilute sulfuric acid of specific gravity of 1.21 or so. Okay, this is about the cathode and anode materials. Coming to the voltage rating, here voltage rating, output voltage of 2 to 2.2 volt output voltage. When fresh, it is should be not used after the voltage fall in 1.85 volt. Whenever this voltage is fall in 1.85 volt, you can't use this, you can again recharge it. Okay, when should be put in charge. Okay, very important. The voltage whenever it is less than 1.5 volt, it can make it charging again. So it has a much larger current capacity as compared to the dry cells considered as earlier. Earlier we discussed the dry cells, right? Compared to that cells, it is a large current capacity. Okay, coming to the usage. So principle of use, these cells are manufactured portable as lead acid batteries, usually automobiles like cars, in your motor vehicles. And for car batteries, 6 cells are connected in series to give the total voltage of 12 volt or more. For traction batteries, railways also, traction is nothing but a railways. In case of railways also, you are using this voltage up to 12 volt, 6 cells are connected in series. That is 64 volt, 32 cells are connected in series to increase the voltage. For industrial like trucks, 30 volts, 15 cells, 72 volt, 56 cells. For the dairy and bakery roads, bakery shops or road vehicles, like we are using this type of cells. Okay, so this is about the all types of cells I explained to you. Coming to this is a theory topic, like somewhat widely, but you need to note down what I gave the important points. What are the important points here? It is a primary or secondary cell, you need to note down. What is a anode material, cathode material, electrolytic solution, applications, uses. Those things are important enough. And then note down the voltage rating. What is the voltage is capable to supply. So coming to the battery rating. So it is a very important question. One of the important question in the previous exam paper. This is one of the question. What is the battery rating? Battery rating of cells or battery rating is ampere hour. Okay, ampere hour is a rating of battery rating of his cells. Battery rating. So lead acid batteries are rated in terms of discharge current, right? It can be supplied continuously for a specific period of time. It is usually expressed as a ampere hour. What is the unit of battery rating? Ampere hour. The capacity is always give the specified rate of discharge 20 hours rate. It means that battery is rated 100 hours and deliver 5 amperes. Battery rated 100 ampere hour. It means, for example, deliver 5 amperes. That means 20 hours is capable to deliver the power. So, and maintain at least 1.5 volt per cell. Of course, the battery can be supplied less current for longer time, more current for shorter time. Okay. So finally, one of the important point here, what is the rating of battery? Ampere hour. Okay. So next, last one, testing of dry cells. So while you are testing of dry cells, this particular cell is connected to the usual load, whatever it may be load, you are connected. In case open circuit voltage is 5 volt, for example. Whenever it is connected to the load and find out that the voltage, will get the 4 volt, for example. So that means the voltage is dropped 5 to 4 volt. This type of voltage drop is present. That means that internal resistance of this particular cell is very high, internal resistance. Then this particular cell is not recommended. Okay, this is the testing procedure. See here, the condition of dry cells or battery can be checked by the internal voltage developed by it connected to the load. That means when voltage is less than 80%, for example, you are given the 100 volt, you will get 79 volt. How much voltage drop? Less than 80%, 79 volt only. So less than 80% is there, the open circuit voltage should be rejected. The drop is less than 80%, it is more than 80%, less than 80%, that means voltage available less than 80%, it is rejected. That means voltage, for example, here again 100 volt, available voltage is 80 volt, okay, more than 80 volt is preferred. So the basic reason is that whenever cells have a high internal resistance which will become a detectable in a cell is tested on load due to normal current flow would be large internal drop and terminal voltage would be drop considerably amount. Such would not be case in the cells tested on load. Okay, whenever you are connected to the load, so whenever voltage is dropping taking place, the internal resistance is very high. So this is about cells, different type of cells and testing of cell and rating of cell. I hope that you are enjoy the class. Of course, this is a theory class, and what important theoretical points I mentioned what are important for you. This is a preparation of about this particular material. What I gave points here, that points are enough to answer in your exam this particular chapter. Thank you.